we want to find the inverse Laplace transform of big F of s, which will give us the function little f of t. And because the inverse Laplace transform of big F of s equals f of t, our first step is to take the inverse Laplace transform of both sides of this equation. So we'd have the inverse Laplace transform of big F of s equals the inverse Laplace transform of 7 divided by the quantity s plus 3 minus the inverse Laplace transform of 3 divided by the quantity 5s minus 2, and then finally plus the inverse Laplace transform of 9 divided by s to the fourth. So looking at the table of Laplace transforms, notice how we're given big F of s, and we're trying to determine little f of t, which means we'll be using this table in this direction here. So looking at the column for big F of s, let's see which formulas apply in order to determine these inverse Laplace transforms. So focusing on the denominators, notice how here we have the quantity s plus 3, and notice how it appears to fit this form here, except here we have s minus a, where a is a constant, and here we have s plus 3. Remember, we can write an addition problem as a subtraction problem, where s plus 3 is equal to s minus negative 3. So we'll be using this row to determine the first inverse Laplace transform. Looking at this inverse Laplace transform, notice how the denominator is 5s minus 2, and even though our denominator here is s minus a, we could factor out 5 to write the denominator in the form of s minus a. So we'll use this formula again to determine this Laplace transform, and then finally here we have denominator of s to the fourth, so we'll be using this row to determine the last inverse Laplace transform, where the denominator is in the form of s raised to the power of n plus 1. So now let's work on making these inverse Laplace transforms fit the correct form on the next slide. Looking at the left side, the inverse Laplace transform of big F of s is equal to little f of t, which is what we're looking for. So we have little f of t equals, for this inverse Laplace transform, let's go ahead and factor out the 7 and write this as 7 times the inverse Laplace transform of, the numerator would now be 1, and because we want the denominator to be in the form of s minus a, let's write s plus 3 as s minus negative 3. For the next inverse Laplace transform, let's factor out 3 and write this as minus 3 times the inverse Laplace transform of, the numerator is 1, and for our denominator, because we want this to be in the form of s minus a, let's factor out 5 and write this as 5 times the quantity s minus 2/5. Notice how if we distribute, we still have 5s minus 2. In the next step, we'll factor out 1/5. For our last inverse Laplace transform, let's factor out 9 and write this as 9 times the inverse Laplace transform of 1 divided by, let's write s to the fourth as s raised to the power of 3 plus 1. Continuing, we have f of t equals, notice how this is exactly the form we want, where the numerator is 1 and a would be negative 3, so we'll leave this alone for right now. Here we don't want this 5 in the denominator, so let's go ahead and factor out 1/5, which would give us minus 3/5 times the inverse Laplace transform of, the numerator would be 1, and the denominator would be s minus 2/5. Notice how now this fits the form perfectly, where a equals positive 2/5. Now for this last inverse Laplace transform, notice how our denominator looks good, where n equals 3, but our numerator must be 3 factorial, and right now it's 1. So let's change this 1 and write 1 as 3 factorial divided by 3 factorial. This would still be equal to 1, and because we want the denominator to be 3 factorial, we'll factor out 1 over 3 factorial and write this as 9 divided by 3 factorial times the inverse Laplace transform of, now the numerator would be 3 factorial, and the denominator is s raised to the power of 3 plus 1. Now all these inverse Laplace transforms are in the exact form that we need in order to apply our formula, which means f of t is equal to 7 times this inverse Laplace transform, where a is equal to negative 3, would be e raised to the power of negative 3t, So the first term of f of t is 7e raised to the power of negative 3t, and then we'd have minus 3/5. For this inverse Laplace transform, a would be equal to positive 2/5. So the second term of f of t would be negative 3/5 times e raised to the power of 2/5 t. And then for the last term, we have plus, let's simplify 9 divided by 3 factorial. 9 divided by 3 factorial equals 9 divided by 3 times 2 times 1, which is 9/6, which equals 3/2. So we have plus 3/2 times, applying this formula where n equals 3, the inverse Laplace transform would just be t to the third. So the third term of f of t is 3/2 t to the third. So going back to our first slide, we now know f of t equals 7e raised to the power of negative 3t minus 3/5 times e raised to the power of 2/5 t plus 3/2 t to the third. I hope you found this helpful.